If you approach the speed of light, would space stretch endlessly ahead of you? Or would it collapse into a single, blinding direction? It's a strange question, because it sounds like science fiction, yet it sits quietly at the heart of real physics. Light speed is not just very fast. It's a boundary written into the structure of the universe itself. As you imagine moving closer and closer to it, familiar ideas begin to loosen. Distance behaves differently. Direction becomes uncertain. Even the act of seeing starts to feel less solid, as if perception itself were being gently unstitched. Welcome back, traveler. Tonight, we drift through science. You might be listening from a dark room, the outside world finally quiet, the glow of a screen fading as the night settles in. Maybe you're stretched out on your bed, or resting on a couch, letting sound replace thought. If this kind of calm exploration helps you slow down, you're welcome to like the video, subscribe, or leave a small comment saying where you're listening from and what time it is for you. There's something grounding about knowing these questions are shared softly across many different nights. If your mind feels busy, tired, or slightly restless right now, that's completely okay. You don't need to arrive here prepared or focused. You don't need to understand every idea or follow every detail. It's fine if your thoughts wander, if images blur, or if parts of this story slip past unnoticed. Nothing here needs to be memorized or solved. This isn't a race for comprehension. It's simply a place where curiosity is allowed to exist without pressure. Tonight, we'll explore what physics actually says about approaching the speed of light, and what that would mean for sight, space, and time itself. We'll move gently between what happens out there in the universe and what humans have done here to understand it. Experiments in laboratories, equations revised late at night, instruments designed to catch single photons with impossible precision. This channel is for people who love big questions but need a calm place to explore them at night. Here on Orbit Sleep, we like to show the universe as it is, and also the quiet human effort of trying to understand it. So tonight, we'll walk carefully through what you'd actually see at light speed, not the cinematic version, but the stranger, quieter reality described by physics. There's no finish line waiting and nothing to prove. You can simply listen and let the images form, fade, or dissolve entirely. If you'd like, you can adjust your pillow, let your shoulders soften, and allow the room to grow still. From here, the journey begins gently, carried forward by curiosity rather than speed. The first tune to understand is that reaching the speed of light is not just difficult, it's fundamentally impossible for anything with mass. But imagining what happens as you approach it is where physics becomes strangely poetic. Long before you ever get close, the universe already begins to behave differently. Vision, distance, and even direction stop acting like familiar companions. What you'd see starts changing quietly, well before anything dramatic happens. At everyday speeds, light behaves politely. Photons bounce off objects, enter your eyes, and form images that feel stable and reliable. You turn your head, and the world follows smoothly. But as your speed increases, this balance begins to shift. Light no longer arrives from all directions equally. Instead, it starts to pile up toward the direction you're moving, as if space itself were leaning forward. This effect is called relativistic aberration, and it's one of the first signs that perception is about to be rewritten. Objects that were once beside you begin sliding toward the center of your view. The universe narrows visually, compressing into a shrinking cone ahead. It's not that space moves, it's that the angles at which light reaches you are changing, subtly at first, then relentlessly. Imagine stars that once filled the sky, now drifting inward, crowding toward a single point in front of you. The edges of your vision grow emptier. Behind you, darkness expands. Ahead, brightness intensifies. You are not moving through a tunnel. The tunnel is forming from the way light reaches you. This is not an illusion. It's geometry under extreme conditions. At high speed, the rules that decide where photons enter your eyes bend, favoring forward directions. Light arriving from behind struggles to catch up. Light from the sides is redirected. Everything conspires to focus vision into what physicists call the headlight effect. With that focus comes brightness. Light isn't just redirected, it's intensified. Photons arriving from ahead are blue shifted, meaning their wavelengths shorten and their energy increases. Dim stars grow brighter. Colors creep toward blue, then violet, then beyond visibility. The universe ahead does not rush past you. It burns brighter instead. This brightness is not comforting. It's not cinematic. It's overwhelming in a quiet, clinical way. Radiation increases. What was once gentle starlight becomes harsh, potentially dangerous energy. Vision is no longer about seeing scenery. It's about surviving the physics of compressed light. Meanwhile, the space behind you fades into irrelevance. Light from the rear can no longer keep pace. Objects there still exist, but their photons fall behind, never reaching your eyes. The universe does not stretch backward. It simply stops reporting itself to you. Distance also begins to behave strangely. Length contraction compresses space in your direction of motion. Objects ahead appear closer than they should be. The universe seems squashed, as if someone gently pressed reality inward from both sides. This is not perspective. It is space-time reshaping itself around your motion. Time joins the distortion as well. Processes ahead appear sped up. Clocks tick faster. Events unfold rapidly, not because they accelerate, but because your frame of reference demands it. Meanwhile, your own internal time slows relative to the outside universe. Seeing and timing are no longer separate experiences. Scientists confirm these effects not through imagination, but through painstaking experiments. Particle accelerators push electrons to speeds incredibly close to light speed. Detectors observe exactly these predicted shifts: forward beaming, energy increase, time dilation. Reality behaves exactly as the equations insist it must. In laboratories, this isn't dramatic, it's precise. Engineers adjust magnets. Physicists monitor readouts. Computers filter noise. The strangeness emerges not with spectacle, but with consistency. Every experiment agrees. As speed increases, perception collapses forward. This is where movies get it wrong. You would not see stars streaking past like rain. You would not experience motion as flow. Motion becomes concentration. The universe does not blur. It compresses. Everything meaningful rushes into a shrinking window ahead of you. And this happens well before light speed itself. Long before the limit, perception is already transformed. The universe begins to feel less like a place you travel through, and more like a signal you receive unevenly. There is something unsettling and calming in this at the same time. You are not outrunning the universe. You are losing access to parts of it. Reality does not disappear. It becomes unreachable, direction by direction. So when you ask what you'd actually see at light speed, the honest answer begins here. You wouldn't see more. You would see less, compressed, intensified, and focused into a single forward-facing truth. A universe no longer wide, but narrow enough to hold in a single glance. As speed increases, the strangest changes don't happen to space first. They happen to time. Not in a dramatic unclock-melting way, but in something far quieter and more unsettling. Events that once felt synchronized begin to lose their shared rhythm. The idea of now, a single moment everyone agrees on, starts to loosen its grip on reality. At everyday speed, simultaneity feels obvious. two lights turn on at the same time. Two sounds reach you together. Cause and effect line up neatly. But this neat alignment is a luxury of slow motion. As you approach light speed, nature reveals that simultaneity was never universal. It was local. From your moving frame, events ahead of you begin to look compressed in time. Things that would normally happen sequentially appear to crowd together. Meanwhile, events behind you stretch out, slowed and delayed. The universe doesn't share one clock anymore. It fragments into overlapping timelines depending on motion. This isn't a visual trick. It's a structural feature of space-time. Einstein showed that time and space are woven together, and motion through one changes how you experience the other. When speed increases, the weave tightens in unexpected ways. Time itself tilts. Imagine distant explosions in space, supernovae, for example. At rest, yes, you might calculate when their light arrives and assume that tells you when they happened. At high speed, that assumption breaks. Light from different moments arrives together. The past bunches up in front of you. What you see is no longer a clean slice of the universe at one instant. It becomes a collage of different times layered into a single view. Ahead of you, ancient light and recent light overlap. Behind you, the universe grows older and quieter, starved of incoming information. Physicists call this the loss of simultaneity. It sounds abstract, but its consequences are deeply sensory. You are no longer observing a shared present. You are intersecting space-time at an angle, skimming across moments that were never meant to align. This effect has been tested repeatedly, not with spaceships, but with clocks. Atomic clocks flown on airplanes tick at different rates than those on the ground. GPS satellites must constantly correct for time dilation, or navigation would fail by kilometers each day. The math is not optional. It governs reality. In labs, scientists don't describe this as time slowing or time speeding up. They describe it as frames disagreeing. Each observer carries their own version of time, shaped by motion. None are wrong, none are privileged. Time becomes relational. As you move faster, your own internal processes remain normal to you. Your thoughts don't race, your breathing doesn't change. Subjectively, nothing feels different. Yet externally, everything is shifting. The universe rearranges its timing around you without asking permission. This is why the idea of seeing at light speed is misleading. Seeing implies a shared present. At extreme speeds, there is no shared present to see. There are only intersecting histories, arriving unevenly at your eyes. Ahead of you, light arrives more rapidly, compressed into fewer moments. Behind you, light thins out, stretched across longer spans. The universe is no longer balanced around you. It leans forward in time as well as space. Even the concept of cause and effect begins to feel fragile. Not broken, but dependent on perspective. What happens first in one frame may not be first in another. The universe remains consistent, but intuition does not survive the transition. Scientists don't experience this as chaos. They experience it as coherence at a deeper level. Equations remain clean, predictions remain accurate. Only the human instinct for before and after struggles to adapt. This realization can feel unsettling at first, but there is also calm in it. Reality does not require a universal clock to function. Order exists without a single timeline. The universe is stable even when time refuses to behave simply. So as speed climbs, what you lose is not vision alone, but certainty. Not clarity, but agreement. The universe doesn't collapse into nonsense. It reveals that now was always a convenience, not a rule. And as this sinks in, something subtle happens. The pressure to keep up with time fades. There is no master clock ticking somewhere beyond you, only motion, perspective, and a reality flexible enough to hold all of them at once. As speed increases further, something even more basic than time begins to unravel: direction. At low speeds, direction feels obvious. Left is left, right is right, ahead and behind feels stable, anchored to your body and the world around you. You can point to where something is and trust that the word means the same thing tomorrow. But near light speed, direction stops being an absolute feature of reality and starts behaving like a suggestion shaped by motion. In everyday life, your sense of direction is reinforced by symmetry. Light reaches you from all around at roughly the same speed. Sounds wrap evenly through space. Gravity pulls downward with reassuring consistency. These cues stitch together a coherent sense of orientation. But as your velocity increases, that symmetry collapses. Information no longer arrives evenly. Stops agreeing on where forward ends and where sideways begins. As relativistic aberration intensifies, nearly all incoming light concentrates into a narrowing region ahead of you. What once felt like a wide field of view compresses into a bright, focused cone. Objects that were clearly to your left or right slide inward, crowding the center. Direction ceases to be distributed. It becomes centralized. The universe begins to behave as if it only has one meaningful direction left. Behind you, direction doesn't reverse. It dissolves. Light from the rear struggles to catch up, thinning until it effectively disappears. There is no dramatic vanishing point. There is simply a growing silence. Space behind you still exists, but it no longer communicates. Direction without information loses its relevance. A place you cannot receive signals from might as well not exist, perceptually speaking. This is not because you are outrunning light in a literal sense. You never do. It is because your motion reshapes the geometry of how light intersects your eyes. Angles distort, paths bend. The universe does not rotate around you. It reprojects itself onto a shrinking perceptual surface. Direction becomes an artifact of speed rather than a fixed feature of space. Physicists describe this effect with clean equations, but its implications are deeply disorienting. At extreme velocities, the idea of a full surrounding environment breaks down. The universe stops feeling like a place you are inside and starts feeling like a signal you are intercepting from one dominant direction. Reality becomes directional in a way it never was before. This shift also changes how distance feels. Objects ahead are length contracted, appearing closer together along your direction of motion. Space itself seems compressed, folded inward. The universe feels denser in front of you, not because matter increases, but because spatial separation decreases. Direction and distance fuse into a single sensation of approach. Human intuition struggles here because it evolved in a regime where direction is reliable. We are built for walking speeds, not relativistic travel. Our brains expect symmetry. They expect space to behave politely. When it doesn't, confusion follows. Yet the universe remains perfectly consistent. It is our expectations that fail, not the physics. Scientists encounter this loss of intuitive direction indirectly through experiments with high-energy particles. In accelerators, particles traveling near light speed emit radiation strongly biased forward. Detectors must be placed carefully, anticipating this directional collapse. The physics is so reliable that engineers design entire facilities around it. Direction at high speed is no longer negotiable. Even cosmic jets from black holes demonstrate this effect on enormous scales. Matter accelerated to near light speed emits energy tightly collimated along its motion. From Earth, these jets appear impossibly narrow, stretching across thousands of light years while remaining sharply defined. Nature itself confirms that at extreme speed, Direction compresses rather than spreads. As direction collapses, the universe loses its sense of around. There is no panorama, no gentle sweep of scenery. Instead, reality presents itself as a focused encounter. Everything meaningful arrives from ahead. Everything else fades into irrelevance. Space stops being immersive and becomes confrontational, narrowed to what you are moving toward. This narrowing is not aggressive. It is quiet and absolute. There is no warning moment where direction announces it is leaving. It simply becomes less useful, frame by frame, until the concept feels outdated. The universe does not explain itself. It just continues behaving according to its deeper rules. At this point, asking what you would see becomes less helpful than asking what you would receive. Vision implies a surrounding world. Reception implies a flow of information shaped by motion. Near light speed, perception becomes an act of interception rather than observation. There is something strangely calming in this realization. The universe is not overwhelming you with more detail. It is offering less. It simplifies itself, not to be kind, but because geometry demands it. Direction falls away because it no longer serves a purpose at that scale. So as speed climbs, direction does not flip, twist, or break. It quietly gives up its role. The universe does not spin around you. It resolves into a single forward-facing relationship between motion and information. And in that narrowing, something profound emerges. When direction disappears, so does the need to orient yourself. There is nowhere to look except where physics insists reality must arrive. The universe becomes not a place you navigate, but a process you momentarily intersect. As direction collapses and time loses its shared rhythm, color is next to change. At ordinary speeds, color feels stable and trustworthy. Red is red. Blue is blue. Light reflects off objects, enters your eyes, and produces hues your brain interprets without question. But color is not a property of objects themselves. It is a relationship between light's frequency and your perception. Near light speed, that relationship begins to slide, quietly but relentlessly. Light arriving from ahead grows more energetic as your speed increases. Its wavelength shortens, shifting toward the blue end of the spectrum. This is not an artistic effect. It is the relativistic Doppler shift, a precise consequence of motion. Starlight that once appeared warm and faint becomes colder, sharper, more intense. The universe does not brighten evenly. It sharpens, concentrating energy into fewer, higher frequency photons. At first, this shift is subtle. Reds drift toward orange, blues deepen slightly. But as velocity climbs, the change accelerates. Colors migrate beyond the visible range entirely. Infrared slides into red. Visible light pushes into ultraviolet. Eventually, even that leaves perception behind. The universe does not glow brighter forever. It crosses thresholds your eyes were never designed to handle. This transformation reveals something important. Vision is not a passive window. It is tuned to a narrow band of reality. When motion shifts light outside that band, sight loses its grip. You are not failing to see. The universe is speaking in frequencies you cannot hear. Ahead of you, energy density increases dramatically. Photons arrive packed tightly in both space and time. What was once gentle illumination becomes radiation. At extreme speeds, even ordinary starlight could pose danger. The universe does not intend harm. It simply follows the math. Energy increases because frequency increases, and frequency increases because motion demands it. Behind you, the opposite happens. Light stretches. Frequencies drop. Blues fade toward red, then into infrared, then beyond visibility. The rear of the universe does not darken suddenly. It cools, slowly slipping out of perceptual reach. Color drains away, replaced by silence rather than blackness. Physicists have observed these effects directly using fast-moving particles and astrophysical jets. When matter travels near light speed, its emitted radiation shifts predictably. Instruments aboard satellites measure these shifts constantly, confirming that color is not fixed in space, but negotiates with motion. Reality keeps receipts. In particle accelerators, scientists design detectors to anticipate extreme blue shifts. Sensors are shielded. Materials are chosen carefully. This is not theoretical curiosity. It is engineering necessity. At high velocities, color becomes energy management, not aesthetics. This reframes what seeing means. Near light speed, sight is no longer about images. It becomes about survival within energetic boundaries. The universe ahead may become too bright to look at, not because it is luminous, but because its information arrives compressed and amplified beyond safe limits. Color, then, stops being descriptive and becomes diagnostic. It tells you how fast you are moving relative to what you observe. Blue means approach. Red means retreat. No interpretation required. Motion writes itself directly into perception. The calmness here comes from predictability. Nothing about this is chaotic. The equations governing color shift are clean and consistent. There is no randomness in how the universe changes tone. It follows a quiet gradient from warm to cold, from visible to invisible. This gradient carries a poetic symmetry. As you move forward, the universe sharpens and intensifies. As you leave things behind, they soften and fade. The future becomes energetic. The past cools into quiet. Motion paints time using color. Human intuition struggles because we associate color with objects, not with movement. We expect a star to remain yellow regardless of speed, but near light speed, identity dissolves into relationship. What something is depends on how you move relative to it. This realization is strangely grounding. The universe is not tricking you. It is showing you its structure honestly. Color is not lying. It is translating motion into sensation, faithfully and without embellishment. Eventually, visible color itself becomes rare. The universe ahead speaks in ultraviolet and beyond. The universe behind whispers in infrared silence. Vision loses its dominance. Other forms of measurement would be required to continue the journey. And so, as speed increases, color does not decorate the experience of motion. It defines its limits. The universe does not rush past in streaks of rainbow light. It shifts tone, frequency, and energy until seeing becomes less about scenery and more about the boundaries of perception itself. As color shifts and direction narrows, another familiar anchor quietly gives way: shape. At human speeds, objects feel solid and dependable. A sphere remains round. A cube keeps its edges. Your eyes trust geometry instinctively. But near light speed, shape stops being an intrinsic property and becomes a negotiation between motion, light, and time. Objects do not merely look distorted. The rules that define their outlines begin to loosen. One of the earliest effects is length contraction. Objects moving relative to you shrink along the direction of motion. This is not a trick of perspective or an illusion caused by speed. It is a real geometric effect, predicted by relativity and confirmed countless times. A spacecraft rushing past you would measure shorter front to back, even though its occupants would notice nothing unusual inside. This contraction does not affect height or width, only the direction of travel. As a result, familiar shapes lose symmetry. A sphere becomes flattened. A rectangle compresses into something unfamiliar. Geometry starts to feel conditional. as if objects are being gently pressed by invisible hands aligned with motion itself. But even this description turns out to be incomplete. Physicists discovered that what you actually see is not simple contraction. Light takes time to reach your eyes from different parts of an object. At high speed, those delays become significant. Different parts of the object are seen at different moments, even though they arrive together in your vision. This produces an effect called parallel rotation. Objects do not just shrink, they appear rotated, warped, or twisted in subtle ways. A fast-moving cube might look partially turned. A sphere may seem oddly intact despite contraction. Shape becomes something your brain reconstructs from mismatched information arriving simultaneously. The universe is not bending objects whimsically. It is enforcing consistency between light speed and geometry. You are seeing different slices of the object's history at once. Shape becomes a composite of time, not a snapshot of space. This realization unsettles intuition deeply. Solidity depends on simultaneity. If you cannot see all parts of an object at the same moment, its form loses coherence. Objects remain real, but their appearance becomes layered, temporal, and difficult to trust. Scientists confirm these effects using particle beams and precise detectors. At CERN and other accelerators, particles traveling near light speed behave exactly as relativity predicts. Their measured lengths change. Their interaction patterns confirm contraction. Shape, at high velocity, is not opinion. It is math. Astrophysics provides another confirmation. Rapidly rotating neutron stars and relativistic jets exhibit apparent distortions that only make sense when light travel time is considered. Astronomers must correct for these effects to avoid misinterpreting observations. The universe demands careful accounting. What's striking is how calm these distortions are. Nothing tears apart. Nothing flickers violently. Shape does not explode into chaos. It gently loses reliability. Edges soften. Symmetry erodes. Objects stop behaving like static sculptures and start behaving like events extended in time. This has consequences for how seeing works. Vision assumes stable forms. It evolved to recognize edges, curves, and solidity at low speeds. Near light speed, those assumptions break down. You are not misperceiving reality. Reality no longer presents itself in a way vision was designed to handle. In this regime, shape is no longer a trustworthy guide to identity. Two objects of the same design may appear radically different depending on their motion relative to you. Form becomes relative, not absolute. Solidity becomes situational. There is something oddly freeing in this. Objects are not lying to you. They are revealing that form was never fundamental. Relationships are. Motion, timing, and information define what appears solid far more than material alone. The universe does not insist on fixed shapes. It tolerates flexibility. Near light speed, geometry adapts to preserve deeper consistency. Space and time cooperate to keep causality intact, even if appearances suffer. This is why the idea of seeing clearly at light speed becomes misleading. Clarity implies stable shapes and reliable outlines. Near this limit, clarity gives way to coherence. The universe remains lawful, but no longer visually intuitive. And so, as velocity increases, shape quietly resigns from its role as a dependable guide. Objects remain real, measurable, and predictable, but their appearance becomes a story told across time rather than space. What you are left with is not visual chaos, but a subtler understanding. Solidity was never guaranteed. It was a low-speed privilege. Near light speed, reality trades form for consistency and appearance for truth. As shape loses reliability, the idea of an object itself begins to feel unstable. At human speeds, objects feel like permanent things that move through space. A chair remains a chair whether you look at it now or later. A star remains a star, even as it drifts across the sky. But near light speed, this stability fades. Objects stop behaving like isolated entities and start revealing themselves as ongoing processes stitched together by time. This happens because an object is never truly present all at once. Even at rest, what you see is light arriving from different moments. At high velocity, those differences grow too large to ignore. Parts of an object belong to different slices of time, even as your brain tries to assemble them into a single thing. The illusion of wholeness becomes harder to maintain. Physics never promised that objects were fundamental. It promised consistency. Near light speed, that consistency is preserved by sacrificing intuition. An object becomes something like a moving agreement between space-time, light, and motion. It exists, but not as a static unit you can fully grasp in a single instant. This is why high-energy physics rarely speaks about things in the everyday sense. Instead, it speaks about interactions, events, and fields. At extreme speeds, particles behave less like solid beads and more like ripples traveling through underlying structures. Identity is defined by behavior, not shape. In particle accelerators, scientists do not track objects as wholes. They track collisions, decay paths, energy transfers. A particle exists meaningfully only in how it interacts. Its presence is inferred through traces, flashes, and statistical patterns. The object dissolves into a story told by detectors. Astrophysics echoes this perspective. Jets emitted by black holes are not single objects moving through space. They are flows of energy, magnetism, and particles evolving over time. When viewed near light speed, they appear distorted not because they are unstable, but because they are processes unfolding faster than intuition expects. As you approach light speed, perception aligns more closely with this process-based reality. You stop encountering things and start encountering transformations. Light arrives not as images, but as signals. Space does not hold objects. It carries relationships between events. This can feel unsettling because human perception is object-oriented by design. We evolved to survive by recognizing stable shapes. We look for continuity. We assume persistence. Near light speed, those assumptions lose usefulness. Reality does not break. Perception does. The universe does not insist that objects remain intact for observation. It only insists that causality remains intact. Effects follow causes. Information does not arrive before it is sent. To preserve these deeper rules, the idea of a neatly packaged object is quietly abandoned. Time plays a central role here. When different parts of an object belong to different moments, identity stretches across duration. An object becomes something closer to a timeline than a thing. What you see is not a snapshot, but a layered exposure. This layered exposure is not messy. It is structured. Physics can predict it with extraordinary precision. Equations remain clean. Detectors remain reliable. Only the visual intuition that expects solid, present objects begins to feel out of place. In this regime, asking, "What is that?" becomes less meaningful than asking, "What is happening there?" Reality prefers verbs to nouns. Motion, interaction, and transformation become the primary currency of existence. There is a quiet elegance in this shift. The universe reveals that objects were never as simple as they seemed. They were always processes moving slowly enough for us to mistake them for things. At high speed, the disguise falls away. This realization carries a strange calm. You are not losing reality. You are seeing it with fewer comforting shortcuts. The universe is not emptying itself. It is clarifying what it values most: consistency over appearance. Near light speed, existence becomes less about holding onto form and more about participating in flow. Objects dissolve into events. Events connect into patterns. Patterns persist even when shapes do not. And so, as velocity increases, the universe quietly lets go of things. What remains is something deeper and steadier. A world defined not by objects occupying space, but by processes unfolding through space-time with unwavering precision. One of the quiet assumptions you carry through everyday life is that there is a single, shared present, a thin slice of time where everything that exists is happening together. It feels obvious, natural. When you look around, the world appears synchronized, as if reality itself were agreeing on what now means. But as speed approaches that of light, this assumption begins to unravel, not violently, not dramatically, but gently, like a thread slipping loose from fabric that was never as tightly woven as it seemed. At low speeds, simultaneity works because differences are too small to matter. Light travels fast enough, and motion is slow enough that timing discrepancies stay hidden. Your brain stitches perception into a clean present without effort. But near light speed, those hidden delays grow large enough to expose the illusion. Events that once felt simultaneous are revealed to be staggered, layered across time, arriving at you from different moments that refuse to align. This is where the concept of now begins to stretch. It no longer behaves like a point on a timeline. It becomes a region, extended, skewed, dependent on motion. From your frame, events ahead of you belong to a different present than events behind you. The universe does not agree on a single moment anymore. It offers many, all equally valid, all incompatible with one another. Einstein called this the relativity of simultaneity, but the name hides how unsettling it really is. It means that the universe does not carry a master clock. There is no cosmic heartbeat ticking in unison everywhere. Time is local. Now belongs to observers, not to reality itself. Motion determines which slice of space-time you intersect, and that slice is never the same for two observers moving differently. As you move faster, your present tilts forward. You encounter future events sooner in the direction of travel, while the past lingers behind you. This is not time travel in the cinematic sense. Nothing jumps, nothing breaks. Instead, the ordering of events depends on perspective. The universe remains internally consistent, but your access to it becomes asymmetrical. This asymmetry changes perception deeply. You are no longer observing a stable present unfolding evenly. You are cutting diagonally through space-time, sampling different moments at once. Vision becomes temporal collage. What you see is not a moment, but a mixture of moments stitched together by light that took different paths and different times to reach you. Physicists test this effect with extraordinary precision. Atomic clocks placed in motion drift measurably from stationary ones. Satellites must correct for this continuously, or their systems fail. GPS, something deeply mundane and practical, only works because engineers respect the fact that now is different in orbit than it is on Earth. Relativity is not philosophical as it is operational. What makes this especially strange is that subjectively, nothing feels wrong. Your thoughts still flow normally. Your breathing stays steady. Your sense of self remains intact. Internally, time feels unchanged. Externally, everything is rearranging itself quietly around you. The universe adjusts its bookkeeping while your awareness remains calm and uninterrupted. This disconnect reveals something profound. The present was never something you inhabited universally. It was something your brain constructed locally, near light speed. That construction no longer matches reality's deeper structure. The universe does not collapse. Your shortcut does. At this scale, the idea of what is happening right now loses precision. Events do not line up neatly across space. There is no universal snapshot to take. Reality exists as a four-dimensional structure, and you are moving through it at an angle, intersecting different layers depending on your velocity. This can feel destabilizing at first. Humans crave shared reference points. We like agreement. We like the comfort of knowing that others exist in the same moment we do. Near light speed, that comfort fades, but what replaces it is not chaos. It is coherence at a deeper level. The universe does not require a single present to function. Causality remains intact. Effects still follow causes. Information still respects the speed of light. Order persists without simultaneity. Reality is more flexible than intuition ever suggested. There is also something quietly comforting here. If now is not absolute, then urgency loosens its grip. There is no cosmic pressure forcing everything to happen at once. Time does not rush forward uniformly. It adapts, stretches, and accommodates motion without complaint. Near light speed, the present is no longer something you stand inside. It becomes something you pass through, a region, not a point, a gradient, not a boundary. The universe stops insisting on synchronization and starts allowing plurality, and in that plurality, something softens. You are no longer late or early in any absolute sense. You are simply moving through a structure vast enough to hold many versions of now at once, without privileging any of them. As this understanding settles, the anxiety of keeping up with time begins to fade. There is nothing to catch, nothing to miss, only different ways of intersecting a reality that was never confined to a single moment to begin with. Once the idea of a universal now dissolves, a deeper question quietly takes its place. If different observers disagree on when events happen, how does the universe prevent chaos? What keeps cause from slipping behind effect? At first glance, relativity seems to threaten the very notion of order. Yet the opposite is true. The universe becomes more disciplined, not less. It tightens its rules precisely where intuition fails, preserving stability even as perspective fragments. In everyday experience, causality feels obvious. You drop a glass, it hits the floor, it breaks, cause comes first. Effect follows. This ordering feels absolute because, at low speeds, time differences remain hidden. Light travels fast enough to keep events neatly aligned. But near light speed, simultaneity fractures, and ordering becomes dependent on motion. The surprise is not that order weakens, it's that it doesn't. Relativity introduces a strict boundary that replaces intuition, the speed of light. No influence, signal or cause, can propagate faster than this limit. This single constraint becomes the backbone of cosmic order. Even when observers disagree about timing, they cannot disagree about causation, if events are connected by signals slower than light. The universe allows flexibility in perception, but enforces rigidity in influence. Physicists visualize this using light cones. Every event casts a cone into space-time, defining which future events it can affect, and which past events could have influenced it. Outside this cone, causation is forbidden. No matter how fast you move, or how time tilts for you, these cones remain inviolate. They are the universe's way of saying, perception may vary, but causality is not negotiable. As speed increases, your flies through space-time changes orientation. but it never crosses these causal boundaries. You may reorder events that are causally disconnected, but anything linked by cause and effect remains locked in sequence. The universe permits ambiguity only where it is harmless. Order survives not by being rigid everywhere, but by being strict where it matters. This is why relativity does not allow paradoxes like receiving information before it is sent. The mathematics closes those loopholes with elegant severity. Even when before and after lose universal meaning, cause remains anchored. The universe sacrifices intuitive ordering to preserve logical consistency. Scientists encounter this principle constantly in high-energy experiments. Particle decays follow strict causal chains, even when observed from different frames. Timing measurements may shift, but the sequence of interactions never reverses. Detectors may disagree on simultaneity, but they never disagree on causation. This distinction is subtle, but profound. It reveals that order was never based on shared clocks. It was based on limits. The speed of light does not merely define how fast things move. It defines how reality protects itself from contradiction. From a perceptual standpoint, this means that near light speed conned events can appear scrambled without becoming nonsensical. Your experience may feel disjointed, layered, or stretched, but the universe underneath remains coherent. Stability does not depend on comfort. It depends on constraint. This has an unexpected calming effect. Even as familiar structures dissolve, shared time, stable direction, reliable shape, something deeper holds steady. The universe does not unravel when intuition fails. It reveals that intuition was never the foundation. Law was. Causality becomes less like a timeline and more like a skeleton. It does not care how events appear. It only cares that influence flows directly. Everything else is negotiable. Perspective may shift. Appearance may warp. Order remains. This perspective reframes speed itself. Approaching light speed does not threaten reality. It exposes its scaffolding. You begin to see how much flexibility the universe allows, and how carefully it guards the few rules that cannot bend. At this scale, before and after become contextual, but because remains firm. Events happen not in sequence alone, but in structure. The universe organizes itself spatially and temporally at once, weaving order through dimensions instead of moments. This is why relativity feels strange but never broken. It trades one kind of certainty for another. You lose the comfort of shared time, but gain the reassurance of absolute consistency. The universe does not drift into ambiguity. It channels it. Late at night, this realization can soften anxiety. Even if your thoughts feel unordered, even if time feels blurred, the larger system remains stable. Disorder in experience does not imply disorder in reality. The universe tolerates variation without losing itself. Near light speed, causality becomes the quiet promise that nothing truly collapses. Events remain grounded. Effects remain faithful to causes. Even when everything else feels unfamiliar, order persists, not because it is visible, but because it is enforced at the deepest level. And as this settles, the universe begins to feel less threatening, not because it is simple, but because it is careful. It allows perception to stretch while guarding meaning, ensuring that no matter how fast you move, reality never forgets how to hold together. When perception fragments and time loses its shared structure, a quieter question surfaces beneath the physics. If the universe no longer agrees on now, what happens to the idea of a continuous self? Identity, after all, relies on sequence. You remember who you were a moment ago, anticipate who you will be next, and call that flowing thread you. But near light speed, sequence itself becomes contextual, and the thread begins to feel less taut. At everyday speeds, the self feels anchored. Your body occupies one place. Your thoughts follow one another in a steady rhythm. Memory stacks neatly behind the present. This creates the impression of a stable observer moving through time. Yet this stability depends on a background where events line up consistently. When simultaneity dissolves, the observer is no longer sitting inside a single timeline. The self becomes embedded in motion. Physics does not describe identity, but it reshapes the stage on which identity forms. If different observers disagree on the order of events, then the story of what happened first becomes perspective dependent. Your experience remains coherent to you, but it no longer claims universal priority. The self becomes local, not absolute. This does not mean identity shatters. It means continuity is maintained internally rather than globally. Your thoughts still flow. Your memories still connect. From the inside, nothing breaks. The disruption happens only when comparing frames. There is no cosmic narrator stitching all cells into one timeline. Each observer carries their own. Scientists encounter this indirectly when modeling fast-moving systems. Particles have lifetimes measured differently depending on speed. Muons created in the upper atmosphere survive longer from Earth's frame than from their own. The particle's experience of existence differs from how it is observed, yet both descriptions are valid. Identity persists without agreement. This suggests something subtle and important. Continuity does not require synchronization. A process can be whole even if it is not universally aligned. Your sense of self does not need the universe to agree on your timing. It only needs internal consistency, which remains intact no matter how fast you move. At near light speeds, perception delivers a layered reality. You receive information from different moments at once. The present becomes extended. Memory and perception blur at the edges, yet your awareness does not fragment. It integrates. The brain does what it has always done. It assembles experience into coherence, even when the inputs are misaligned. This reveals that identity was never built on objective simultaneity. It was built on narrative. The self is a story told continuously by a system that remembers, predicts, and updates. That story adapts effortlessly to changes in frame because it was never dependent on a universal clock to begin with. In this sense, relativity does not threaten the self. It demotes it from cosmic significance. You are no longer an observer standing at the center of a shared present. You are a participant moving through space-time along a unique path. Your identity belongs to that path, not to the universe as a whole. There is something calming in this demotion. The pressure to be in sync with everything else dissolves. You are not late or early in any absolute sense. You are simply where you are along your world line, carrying your memories forward in a way that remains uninterrupted from within. Philosophers sometimes worry that relativity undermines personal identity. Physics quietly suggests the opposite. Identity was always relative. It was always situated. The universe never promised a single objective viewpoint from which all cells could be compared fairly. Near light speed, this becomes explicit. You are not observing reality from outside. You are embedded within it, moving along a trajectory that defines what you can see, remember, and anticipate. The self becomes less like a detached witness and more like a process unfolding. This process does not feel fragile. It feels robust. Even as perception warps and time stretches, awareness remains continuous. The self is not tied to simultaneity. It is tied to causality, to the fact that your experiences follow from one another without interruption. That distinction matters. Causality, as you've seen, is protected even at extreme speeds, because your internal states remain causally connected. Identity remains intact. The universe allows perception to bend, but it does not allow the self to fracture. Late at night, this understanding can be grounding. You do not need the world to make sense globally to remain whole locally. Confusion in perspective does not imply confusion in being. Your continuity is carried with you, frame by frame. Near light speed, the universe stops asking who you are in absolute terms. It asks only how you move, how you connect moments, and how your experience unfolds along its own path. Identity becomes quieter, humbler, and more resilient. And as this settles, the self feels less like a fixed point and more like a gentle motion through space-time, consistent, uninterrupted, and sufficient, even when the universe itself refuses to agree on what time it is. After everything that is shifted, direction collapsing, color sliding beyond sight, shape dissolving into process, time losing its shared present, one assumption quietly remains. That seeing is still the main way you encounter reality. But near the speed of light, even that assumption begins to loosen. Vision, which once felt like a reliable bridge between you and the universe, starts to feel secondary. Not broken, not useless, simply no longer central. At human speeds, seeing feels like understanding. You look at something and you feel oriented. The world presents itself visually, and meaning seems to follow naturally. But near light speed, vision becomes overloaded, distorted, compressed, or stripped away entirely. Information arrives unevenly. Frequencies shift beyond perception. Shapes lose stability. The eye is no longer the privileged interpreter of reality. This is not because reality becomes inaccessible. It's because reality stops prioritizing surfaces. Near light speed, what matters most is not appearance, but structure. Not what something looks like, but how information flows, how events connect, how causality remains intact beneath perception. The universe becomes less cinematic and more architectural. Physicists learned this lesson long ago. In high-energy environments, scientists do not rely on images. They rely on traces, probabilities, interaction patterns. Reality is inferred through mathematics and consistency rather than direct sight. What is real is not what is visible, but what behaves lawfully under extreme conditions. Near light speed, you would experience something similar. Seeing would no longer feel like looking at the universe. It would feel like intersecting it. Information would arrive as gradients of energy, timing, and intensity, rather than recognizable scenes. Vision would fade into measurement, even if no instruments were present. This does not mean experience becomes empty. It becomes quieter, simpler. Fewer distractions survive. The universe offers less decoration and more structure. Less scenery, more rule. It is not impoverished, it is distilled. In this distilled state, something surprising happens. Anxiety begins to fall away. Much of human unease comes from trying to reconcile what we see with what we expect. Near light speed, expectation loses authority. You are no longer comparing reality to intuition. You are simply receiving what arrives. This is why the approach to light speed does not feel chaotic at its core. It feels minimal. The universe removes unnecessary features while preserving the essentials. Causality remains. Consistency remains. Identity remains. What falls away are the comforting illusions of completeness and immediacy. Seeing less does not mean knowing less. In fact, it often means knowing more accurately. Vision is a convenience optimized for survival, not truth. Near light speed, the universe stops catering to survival-scale perception and starts revealing its deeper priorities. There is a strange peace in that. The universe no longer performs. It no longer presents itself for interpretation. It simply behaves, and you, moving within it, are no longer spectator. You are a participant intersecting lawful processes in motion. This reframes the entire question of what would you actually see at light speed? The honest answer is that seeing stops being the right verb. Experience becomes about receiving constraints, not images, about alignment, not observation, about structure, not scenery. At this point, the journey could end, but it shouldn't, because everything up to now has only prepared the ground. We've stripped away intuition, perception, and comfort. What remains is the universe's deeper skeleton, and that skeleton still has much to show. Beyond this point lie questions even quieter and more demanding. What happens to distance itself when motion dominates? What happens to space when time stretches infinitely? What does it mean to arrive anywhere if arrival requires infinite energy? These are not footnotes. They are the natural continuation of what we've begun. So instead of closing the story here, we leave a door open. What you've explored so far is what falls away as you approach the speed of light. What comes next is what remains. The deep, sparse, unyielding structure that still holds the universe together when almost everything familiar is gone. And from here, the journey slows even further. We step into questions that do not have visual answers at all. Questions about limits, asymptotes, horizons, and why the universe draws an uncrossable line and calmly refuses to let anything pass. If you're still listening at this point, you've already let go of the easy parts. The next stretch is quieter, deeper, and less forgiving, but also more stable, more honest, and more strangely comforting than anything we've seen so far. From here on, we're no longer asking what you would see at light speed. We're asking what the universe becomes when speed itself reaches its limit, and why it insists on keeping that limit forever. One of the most misunderstood ideas in physics is the notion of reaching the speed of light. Movies treat it like a milestone you simply cross if you accelerate long enough. Reality is far less dramatic and far more rigid. Light speed is not a fast lane on a cosmic highway. It is a boundary built into space-time itself, one that resists being touched in a very specific, very unforgiving way. As you accelerate closer to light speed, something counterintuitive happens. Your velocity increases, but each additional increase requires more energy than the last. Not linearly more, exponentially more. The closer you get to light speed, the steeper the energy curve becomes, as if motion itself were pushing back harder and harder against your attempt to go faster. This resistance is not friction. Space is not thickening. Nothing is physically blocking you. The universe is enforcing a rule through geometry. Energy you add no longer translates efficiently into speed. Instead, it goes into increasing momentum, warping space-time relationships, and deepening relativistic effects without granting the final increment of velocity. In mathematical terms, light speed is an asymptote. You can approach it forever without ever arriving. No matter how much energy you add, the remaining gap never disappears. It shrinks, but it never reaches zero. This is not a technical limitation of engines or materials. It is a structural feature of reality. Particle accelerators demonstrate this with absolute clarity. Electrons are pushed to speeds astonishingly close to light speed, often exceeding 99.99999% of it. Yet no matter how much energy scientists inject, the particles never cross the limit. Instead, their energy increases while their speed barely changes. Motion saturates. This saturation reveals something important. Light speed is not about how fast light moves. It is about how space-time itself permits relationships between events. It defines the maximum rate at which cause can lead to effect. Anything with mass is bound by this rule because mass anchors objects to space-time in a way light is not. Photons move at light speed, not because they are energetic, but because they are massless. They do not experience time or distance in the same way. For them, emission and absorption are not separated by duration. For anything with mass, that shortcut is unavailable. Time refuses to vanish completely. As you accelerate, time dilation grows without limit. From an external frame, your clock slows, your processes stretch, your journey elongates. From your own frame, nothing feels strange. But the universe demands compensation. If speed increases, time must pay the price. This is why reaching light speed would require infinite energy. Infinite energy is not something the universe tolerates casually. It destabilizes equations, breaks conservation laws, and destroys consistency. Rather than allowing this, the universe erects an unreachable boundary and calmly enforces it. There is no moment where you feel almost there. The experience of approaching light speed is one of diminishing returns. Each push forward yields less progress. Motion becomes expensive. Advancement slows. The limit asserts itself quietly, without drama. This makes light speed fundamentally different from other physical limits. It is not a wall you crash into. It is a horizon you never reach. No collision, no explosion. Just endless approach. The universe seems deeply invested in this behavior. Many of its laws are written to avoid infinities. Whenever infinity appears, physics treats it as a sign something deeper is missing or protected. Light speed is one of the places where the universe draws a firm line and refuses negotiation. Emotionally, this can feel frustrating. Humans are wired to believe that persistence eventually yields arrival. Relativity denies this intuition. Some destinations are defined precisely by being unreachable. They exist as limits, not locations. But there is also stability in this refusal. By preventing anything with mass from reaching light speed, the universe preserves causality, coherence, and structure. Without this limit, cause and effect would collapse into paradox. Order would unravel. Light speed is not a challenge to overcome. It is a condition to live within. It defines the shape of possible journeys, not their success or failure. You are not meant to arrive there. You are meant to move meaningfully beneath it, and this realization changes the tone of the journey entirely. From here on, the question is no longer about speed. It is about what it means to exist inside the universe that allows approach but never arrival, and why that restraint may be the very thing that keeps reality calm, consistent, and habitable. As you continue approaching the speed of light, distance undergoes a transformation that feels almost unfair to intuition. At low speeds, distance is comforting. A road has a length. A journey has a duration. You expect effort to translate into arrival. But near light speed, distance begins to detach from these expectations. It no longer behaves like a gap waiting to be crossed. It becomes something elastic, relational, and increasingly abstract. From an external frame, the distance you are trying to traverse remains unchanged. The stars ahead stay where they are. The destination does not move closer. Yet from your own frame, something remarkable happens. Length contraction compresses the space in front of you. The distance shrinks. What once seemed impossibly far appears closer, not because you are winning against space, but because space-time itself is adjusting to preserve its internal rules. This creates a strange dual truth. Externally, the journey grows longer. Internally, the distance collapses. Both descriptions are correct. Neither cancels the other. The universe allows distance to depend on motion, even while insisting that light speed remains unattainable. You are permitted to experience shrinking space, but not infinite velocity. This is why astronauts traveling near light speed could, in principle, cross enormous cosmic distances within their own lifetime. Entire galaxies could pass beneath their journey, while their internal clocks barely advance. Distance, whole from their perspective, becomes negotiable. Time pays the price instead. Yet this negotiation has limits. Even as distance contracts, arrival still refuses to occur in the way intuition expects. The closer you get to light speed, the less meaningful how far becomes. Distance stops being about meters or light years and starts being about causal separation. What matters is not how much space lies ahead, but whether information can still flow meaningfully. This is where distance quietly merges with horizon. Beyond certain points, events may still exist, but they fall outside your ability to interact with them. They are not unreachable because they are far. They are unreachable because space-time no longer allows a causal path. Distance becomes a question of permission rather than measurement. Cosmology confronts this daily. There are regions of the universe whose light will never reach us, no matter how long we wait. Expansion carries them away faster than light can bridge the gap. These galaxies are not behind walls. They are beyond causal reach. Distance, in this sense, is defined by fate, not space. Near light speed, your personal experience begins to echo this cosmic truth. You can see destinations drawing closer in contracted space, yet still never truly arrive. The journey becomes asymptotic. Progress continues, but completion dissolves. Distance transforms from something to conquer into something to approach indefinitely. This reframing can feel deeply frustrating if you expect travel to obey effort. But physics is not designed around effort. It is designed around consistency. Distance adjusts to motion in ways that preserve causality, not human satisfaction. Engineers and physicists treat this with quiet acceptance. When planning missions, they calculate not just distance on but reference frames. They acknowledge that distance is not a single number. It is the relationship between the observers, clocks, and motion. Navigation becomes geometry, not geography. Emotionally, this realization changes the tone of movement. You stop thinking in terms of destinations and start thinking in terms of trajectories. A path through space-time matters more than an endpoint in space. Existence becomes directional rather than goal-oriented. There is a subtle calm in this shift. If arrival is not guaranteed, pressure dissolves. Motion does not need to justify itself by completion. A journey can be meaningful without ending. Distance no longer demands conquest. It simply exists as structure. Near light speed, the universe seems to whisper this lesson repeatedly. You are allowed to move, to approach, to explore, but not to collapse separation entirely. Distance is softened, not erased. It becomes negotiable, not eliminable. This is why the idea of reaching light speed feels misplaced. The universe is not offering a finish line. It is offering a boundary that reshapes how movement, time, and distance relate to one another. You are meant to live inside this relationship, not defeat it. And as distance loses its old meaning, a deeper question begins to surface. If neither speed nor distance guarantees arrival, then what does arrival even mean in a relativistic universe? That question waits quietly ahead, opening the path to what comes next. When distance stops behaving like a simple gap, another concept quietly takes center stage. The horizon, not a physical edge, not a barrier you collide with, but a boundary defined by motion, time, and causality. Horizons are easy to misunderstand because they do not announce themselves visually. There is no line in space where reality ends. Instead, horizons are regions beyond which interaction quietly becomes impossible, not because of obstruction, but because space-time itself refuses to cooperate. The most familiar horizon is the event horizon of a black hole. From far away, nothing appears special about it. Space looks normal. Light still travels, yet once crossed, return becomes impossible. Not because something pulls harder, but because all possible future paths point inward. The horizon is not a wall. It is a change in what futures are allowed. A similar logic applies to horizons created by motion. As you accelerate toward light speed, your causal reach reshapes itself. Regions of space-time fall behind your ability to interact with them. Signals from behind arrive slower and slower. Eventually, they no longer arrive at all. A horizon forms not because space ends, but because communication fails. This kind of horizon does not sit still. It follows you. It is attached to your motion, your frame, your trajectory through space-time. The faster you move, the more aggressively the horizon reorganizes what remains reachable. Reality does not disappear. It simply exits your future. Cosmology reveals this effect on the largest scales. The expanding universe creates a cosmic event horizon. There are galaxies whose light will never reach Earth, no matter how long time continues. They are not hidden. They are not blocked. Expansion stretches space-time so that light emitted today will never close the gap. The horizon is temporal, not spatial. Near light speed, your personal experience mirrors this cosmic behavior. As motion increases, parts of the universe slip permanently into your past. You cannot turn back to retrieve them, not because you lack power, but because the structure of space-time no longer permits a path that reconnects. This challenges the intuition that horizons mark dramatic transitions. In reality, nothing special happens at the moment you cross one. No alarm sounds, no visual distortion announces the change. The difference appears only later, when return or interaction is attempted and quietly fails. Physicists treat horizons with deep respect because they encode limits of knowledge, not just limits of motion. Beyond a horizon, events may still occur, but they can never influence you. For all practical purposes, they are removed from your universe. Reality becomes observer-dependent in a very literal sense. This does not mean the universe fragments arbitrarily. Horizons obey precise mathematical rules. Their location can be calculated, their behavior predicted. They are not signs of chaos, but of order enforced through limitation. The universe uses horizons to maintain consistency across vast scales. Emotionally, horizons can feel unsettling. Humans prefer boundaries that can be tested, pushed against, or crossed. Horizons resist this impulse. They define regions not by resistance, but by irrelevance. What lies beyond is not forbidden. It is simply unreachable. Near light speed, this irrelevance becomes personal. Parts of reality fall away not because they are destroyed, but because they no longer matter to your future. The universe becomes selective, trimming what it allows you to interact with while preserving internal coherence. This selectivity introduces a strange calm. If not everything can reach you, then not everything needs your attention. Horizons simplify existence by limiting influence. They reduce the burden of totality. The universe becomes manageable not by shrinking, but by structuring access. Scientists often describe horizons as information boundaries. What you can know, measure, or affect is constrained not by curiosity, but by space-time geometry. Near light speed, these constraints tighten. Knowledge becomes local. Influence becomes directional. This reframes the idea of exploration. you are not moving toward an edge of space. You are moving within a structure that continuously redraws the boundary of what can matter to you. Exploration becomes relational, not territorial. At this point in the journey, the universe begins to feel less like an open landscape and more like a carefully regulated system. Freedom exists, but it is bounded. Motion is allowed, but not without consequence. Horizons enforce these consequences quietly and without exception. As this settles, another question rises naturally. If horizons define what can never be reached, then what role do limits play in making the universe livable at all? Why does reality prefer unreachable boundaries over infinite access? That question waits just ahead, opening the path to what comes next. When horizons but resists arrival. This is not an accident or a flaw in our understanding. It is a recurring design principle woven deeply into the structure of physical law. Infinity is seductive to the human mind. It feels like freedom without boundary, motion without restraint, knowledge without end. But in physics, infinity is rarely welcomed. Whenever an equation produces an infinite value, it signals not triumph, but trouble. It tells physicists that a model has been pushed beyond where it can meaningfully describe reality. Light speed is one such corrective boundary. Instead of allowing velocity to grow without limit, the universe bends time, compresses space, and increases energy requirements until progress slows to a crawl. Motion approaches a ceiling, not because engines fail, but because space-time enforces restraint. The limit protects coherence. This same behavior appears in gravity. Singularities, points of infinite density, are predicted by equations, yet never directly observed. The universe hides them behind horizons, shielding the rest of reality from their pathological extremes. Infinity is acknowledged, but isolated, prevented from contaminating the larger structure. Quantum mechanics tells a similar story. Energy levels are quantized. Particles occupy discrete states. Continuous infinity is replaced by stepwise limitation. Nature does not allow arbitrary values everywhere. It prefers ranges, thresholds, and constraints that preserve predictability. These limits are not restrictive in a human sense. They are stabilizing. Without them, cause and effect would lose meaning. Signals could arrive before they were sent. Energy could explode without bound. Time could fracture entirely. Limits are the scaffolding that keeps reality inhabitable. Near the speed of light, this scaffolding becomes visible. You feel the resistance not as a force, but as a refusal. The universe does not argue. It simply does not permit certain transitions. You can approach forever, but crossing is not an option offered by the rules. There is a quiet elegance in this refusal. Instead of dramatic barriers, reality uses asymptotes. Instead of walls, it uses diminishing returns. The closer you get to the edge, the slower progress becomes. Limits announce themselves through patience, not violence. Physicists respect this behavior because it appears everywhere. Wherever infinity threatens to appear, a boundary follows. Wherever unconstrained growth could destabilize structure, a rule intervenes. The universe seems deeply invested in remaining internally consistent, even at the cost of denying absolute freedom. Emotionally, this can feel disappointing. Humans like finish lines. We like arrival. But the universe is not structured around satisfaction. It is structured around survivability. A reality without limits would not persist long enough for observers to ask questions about it. Limits make space for complexity. By preventing extremes, they allow systems to develop gradually. Stars can burn steadily. Galaxies can form without tearing themselves apart. Life can emerge without being instantly erased by runaway forces. Near light speed, you begin to sense this protective quality. The universe is not teasing you with unreachable speed. It is preventing collapse. The limit is not there to frustrate motion, but to preserve everything else that depends on motion behaving responsibly. In this way, limits are not the opposite of freedom. They are the condition for it. Within boundaries, patterns can exist. Without them, nothing holds shape long enough to matter. The universe chooses limitation so that meaning can survive. As this understanding settles, the presence of horizons and asymptotes no longer feels cruel. It feels intentional. Reality is not unfinished. It is carefully bounded. It allows approach, curiosity, and exploration, while quietly denying the one step that would unravel everything. This brings a deeper calm to the journey. You are not failing to reach something forbidden. You are moving within a system that knows exactly where it must stop itself to remain whole. And with that calm comes another question, softer but heavier. If limits are everywhere, and infinity is always kept at a distance, what does that say about the meaning of progress itself? That question opens the next stretch of the path. There is an emotional weight to limits that physics rarely names directly. Humans are wired to move toward goals, to believe that effort accumulates into arrival. We measure progress by milestones passed and distances closed. But a universe built around a symplotic quietly disrupts this narrative. Near the speed of light, motion continues without completion. You advance endlessly without ever arriving. This is not failure. It is a different geometry of meaning. At first, unreachable destinations feel frustrating. They resemble promises withdrawn at the last moment. The closer you get, the clearer the denial becomes. Progress slows. Rewards diminish. The finish line recedes without explanation. But this frustration comes from importing human expectations into a system that was never designed to satisfy them. Physics offers no consolation in the language of achievement. It offers structure. It says, motion is permitted, arrival is not guaranteed, and value is not measured by completion. A journey does not need an endpoint to be real. It needs coherence. Near light speed, coherence replaces conquest as the organizing principle of experience. This reframes the emotional texture of travel. You stop asking how far remains and start noticing how motion reshapes everything along the way. Time stretches, space compresses, perception simplifies. The journey becomes less about destination and more about transformation. What changes is not where you are, but how reality behaves around you. Cosmology reflects this same emotional logic. We observe galaxies whose light we will never receive. We calculate distances we will never traverse. The universe does not hide these facts. It presents them calmly as features rather than tragedies. The unreachable is not an error. It is part of the design. Living in such a universe requires a different relationship with desire. Wanting does not obligate fulfillment. Curiosity does not guarantee possession. The universe allows you to know about things without ever allowing you to have them. Knowledge replaces ownership. There is a quiet maturity in this arrangement. If everything were reachable, nothing would retain mystery. If every approach ended in arrival, motion would collapse into routine. Limits preserve depth. They ensure that some questions remain open without being broken. Near light speed, this becomes personal. You feel the tension between effort and outcome dissolve. You are no longer chasing something that will eventually submit. You are participating in a structure that remains larger than your trajectory. The universe does not bend to meet you. It lets you move within it. This can feel humbling, but it can also feel relieving. The pressure to finish eases. The anxiety of completion fades. Motion becomes sufficient on its own. Progress no longer demands closure to justify itself. Scientists live with this mindset daily. They work toward theories they know will remain incomplete. They refine measurements that approach truth without exhausting it. In physics, understanding is always asymptotic. Each answer clarifies the question without erasing it. Near the speed of light, existence mirrors this scientific posture. You move closer to limits not to cross them, but to learn what they protect. The journey teaches you the shape of reality by showing you where it refuses to go. Emotionally, this can soften ambition into attentiveness instead of racing toward an endpoint. You begin to listen to what the structure itself is saying. Limits stop feeling like denial and start feeling like guidance. There is a kind of trust required here. Trust that meaning does not depend on possession. Trust that motion without arrival is not wasted. Trust that the universe is not withholding something sensual by refusing infinite access. As this trust settles, unreachable destinations lose their sting. They become reference points rather than goals. You orient yourself by them without needing to arrive. They give shape to motion without demanding resolution. In a universe that prefers approach over completion, rest becomes possible inside movement itself. You are not behind. You are not unfinished. You are exactly where motion places you, within a system that values consistency more than closure. And as this perspective deepens, attention naturally turns to something even quieter. If limits shape motion and meaning so profoundly, then perhaps rest itself is not the absence of movement, but a different way of inhabiting it. That thought lingers, waiting to be followed. When destinations stop defining meaning, rest quietly changes its role. At human scale, rest is usually imagined as stillness. You stop moving, you pause, you arrive somewhere safe and let effort dissolve. But near the speed of light, stillness is no longer the opposite of motion. Everything is already in motion. Galaxies drift, space expands, time flows differently for every observer. In such a universe, rest cannot depend on stopping. It must exist inside movement itself. Physics hints at this long before philosophy does. Even particles accelerated to extreme energies settle into predictable behaviors. Their motion stabilizes. Their interactions become regular. Near light speed, acceleration does not lead to chaos. It leads to saturation. Change slows, variation narrows. The system enters a kind of dynamic equilibrium where motion continues, but novelty decreases. This is a subtle form of rest, not the absence of activity, but the absence of escalation. Nothing new is demanded. Nothing dramatic is about to happen. The universe keeps moving, but it stops asking for additional effort. Progress becomes smooth rather than urgent. From your own frame, this feels surprisingly calm. Time dilation stretches external events, spacing them farther apart. The outside universe slows. Processes unfold gently. You are still moving, still existing, still changing, but the pace softens. Motion no longer feels like strain. This reveals that rest was never about immobility. It was about predictability. Systems feel restful when they stop surprising themselves. Near light speed, many variables freeze into stable relationships. Direction narrows, causality locks in, horizons define reach. The universe simplifies. Human nervous systems crave this kind of simplicity. Much of stress comes from excessive branching, too many possible outcomes, too many demands arriving at once. Relativistic motion quietly reduces branching. Futures become constrained, possibilities narrow. The universe becomes less noisy. There is also something comforting in the way limits hold everything together. You are not responsible for crossing them. You are not expected to resolve infinity. The universe has already decided where motion must slow, where arrival must fail, where boundaries must stand. You are allowed to exist inside those decisions without resisting them. Scientists experience a version of this calm when equations converge, when models stabilize, when predictions stop changing wildly and settle into consistent behavior. Understanding does not explode outward forever. It settles inward. Knowledge becomes quieter. Near light speed, experience mirrors this intellectual calm. You are no longer racing towards something undefined. You are moving within a structure that no longer surprises you with impossible demands. Motion becomes familiar, even when extreme. This reframes rest as alignment rather than withdrawal. You rest when your expectations match reality's rules. Near light speed, expectations finally give up their claim to dominance. Reality sets the pace, and you follow without protest. There is no heroism in this, no triumph, just acceptance. The universe is vast, constrained, and unapologetic. It does not rush. It does not negotiate its limits. It simply continues and allows you to continue with it. This acceptance carries emotional weight. When you stop fighting for arrival, exhaustion lifts. When you stop demanding completion, attention widens. Rest appears not at the end of motion, but at the moment resistance ends. Even thought itself begins to behave differently here. Without the pressure of resolution, ideas can float without needing closure. Curiosity exists without urgency. Questions do not have to collapse into answers. They can remain open without causing tension. The universe seems comfortable with this openness. It does not rush to finish itself. It expands patiently. It allows the horizons to form. It allows limits to persist. Rest is built into its behavior, not added afterward. In this sense, approaching the speed of light does not feel like running toward something unbearable. It feels like entering a regime where struggle becomes unnecessary. Motion continues, but effort fades. Change persists, but urgency dissolves. This may be one of the quiet lessons hidden inside relativistic physics. That rest is not found by stopping the universe, but by understanding how it prefers to move. When you move in harmony with its limits, tension drains away. And once this harmony is felt, attention naturally drifts toward a deeper question. If rest can exist inside motion, then perhaps stillness itself was never required. Perhaps calm has always been available, hidden not at the end of the journey, but woven gently into the way the universe moves at its limits. As this sense of rest settles into motion, another assumption begins to loosen almost without resistance. The idea that calm depends on certainty. At human scale, uncertainty feels threatening. Not knowing where something leads creates tension, but near the speed of light, certainty is no longer available in the way intuition expects. Destinations remain unreachable, timelines remain relative, and perception remains incomplete. And yet, the system does not feel unstable. It feels composed. Physics does not reward certainty. It rewards consistency. A model does not need to know everything to function. It only needs to avoid contradiction. Near light speed, the universe abandons the promise of full clarity while fiercely protecting coherence. You may not know exactly where you are in a universal sense, But nothing you experience violates the rules that hold reality together. This creates a form of trust that does not rely on prediction. You stop asking what will happen next in an absolute sense. Instead, you learn how change behaves. Motion becomes familiar even if outcomes remain open. This is different from confidence. It is orientation without destination. Scientists working at the limits of theory recognize this feeling well. When equations approach regimes they cannot fully describe, they do not panic. They mark boundaries, respect constraints, and continue working within what remains reliable. Uncertainty is not failure. It is a signal that the structure is larger than the current description. Near light speed, experience adopts this same posture. You stop demanding that perception explain itself completely. You stop insisting on full resolution. Reality does not collapse when explanations thin out. It continues quietly, governed by principles that remain intact even when interpretation falls behind. This is where fear tends to dissolve. Much fear is born from imagining that losing clarity means losing control. Relativity shows the opposite. Control was never the goal. Consistency was. The universe is not asking you to understand everything it does.
It only asks that you move within its constraints. There is also something deeply non-judgmental about this regime. The universe does not care whether you approve of its limits. It does not punish curiosity. It does not reward obedience. It simply behaves. This neutrality removes pressure. You are not being tested by the cosmos. You are being carried by it. As motion stabilizes near its limit, experience becomes less about anticipation and more about presence. Not presence as mindfulness rhetoric, but presence as necessity. With no guaranteed arrival, attention stops projecting forward endlessly. It settles into what is available. This is not resignation, it is adaptation. Even identity responds to this shift. When the future no longer promises closure, the self loosens its grip on outcome. You exist less as a project and more as a process. Continuity remains, but ambition softens. The self becomes something that unfolds rather than something that completes. This unfolding mirrors the universe itself. Expansion without finish, motion without arrival.
Structure without finality. Near light speed, you are not resisting this pattern anymore. You are aligned with it. Calm arises not because things are resolved, but because resistance has nowhere left to stand. At this point, questions about speed, distance, and limits begin to feel less technical and more atmospheric. They shape the background rather than the foreground. You no longer interrogate them actively. They simply frame experience quietly. This is often where people expect existential dread to appear, but it doesn't. Instead, something gentler arrives, a recognition that the universe does not require urgency to function. It allows patience at the deepest level. Nothing important is rushing. The closer you move to fundamental limits, the slower reality seems to ask you to think. Complex demands fall away. Only the most basic rules remain relevant. Causality, consistency, continuity. Everything else becomes optional decoration. This is why extreme physics often feels paradoxically peaceful. It strips experience down to what cannot break. The universe reveals what it protects when everything else. As motion finally begins to ease, something subtle happens to perception. Not a snap back to normality, but a slow re-thickening of experience. Distances regain texture. Time starts to feel layered again, no longer stretched thin into near stillness. The universe does not rush you back. It lets familiar sensations return gradually. like warmth creeping into a room after a long night. This return is not a loss. What you carry back is not speed, but perspective. Having moved near a fundamental limit, everyday motion feels different. Walking, breathing, watching light shift across a wall, all of it now sits inside a larger context. You have felt what happens when change nearly stops accelerating, and that memory reshapes how ordinary flow feels. Physics calls this symmetry breaking. Conditions change, and behaviors reappear. The rules never left, but their effects become visible again. At low speeds, time resumes its familiar rhythm. Space stops compressing noticeably. Directions regain meaning. Yet beneath all of this, the deeper structure remains unchanged, quietly governing everything without drawing attention to itself. There is a humility in this realization. The universe does not reveal its limits dramatically. It lets you approach them, feel their presence, and then return without ceremony. Nothing is announced. Nothing is celebrated. Reality simply continues operating as it always has, indifferent to whether you noticed its deeper layers or not. Human life unfolds entirely in this slow regime. We live far below light speed, far from extreme gravity, far from cosmic horizons. And yet, those distant limits still shape every moment. They define causality. They protect order. They quietly ensure that yesterday leads to today, instead of unraveling into chaos. Knowing this does not make daily life feel smaller. It makes it more grounded. Every mundane action exists because the universe refuses infinity, because limits hold, because time does not shatter. Ordinary moments are supported by extraordinary constraints that never announce themselves. There is also comfort in realizing how much is handled for you. You do not need to manage space-time. You do not need to negotiate causality. The universe has already solved the hardest problems required for experience to exist at all. Your role is not to control, but to inhabit. As speed drops further, ambition and urgency regain their voices. But they sound different now, softer, less absolute. Goals still matter, but they no longer feel cosmic. They belong to human scale again, where effort and outcome can meet without contradiction. This is where meaning stabilizes. Not at the extremes, but in the return. The universe allows you to visit its boundaries not to escape ordinary life, but to re-enter it with altered proportions. What once felt overwhelming now feels contextual. What once felt urgent now feels optional. Scientists often describe this sensation after working too long on abstract problems. When they step away from equations describing infinity and singularity, the physical world feels almost tender. Coffee cups, streets, voices, all improbably intact. Reality feels sturdy again. Near light speed, you glimpsed how fragile coherence could have been, and how carefully it is preserved. Coming back, that preservation feels like a gift, not dramatic, not sentimental, just quietly reliable. The universe does not ask you to remember every detail of the journey. It does not expect comprehension to survive intact. What remains is simpler, a sense that beneath confusion, beneath speed, beneath complexity, there is a structure that holds. And once you feel that structure, rest becomes easier, sleep becomes possible. Thought can loosen its grip without fear of falling into nothing. The universe is not waiting to collapse the moment attention drifts. As perception settles fully back into human rhythm, there is no need to hold on tightly to what you learned. Understanding does not vanish when attention softens. It becomes part of the background, quietly informing how the world feels. The speed of light fades from awareness, returning to its role as an invisible boundary rather than an active presence. And yet, its influence remains everywhere, in every cause that follows effect, in every moment that arrives when expected, in every night that gently allows consciousness to rest. The journey does not end with a conclusion. It dissolves back into ordinary motion, carrying with it a subtle reassurance. Reality is constrained, consistent, and patient. You are not required to outrun it. You are already moving exactly as fast as you need to, becomes flexible. And what it protects is surprisingly little, but sufficient. As this quiet holds, attention naturally begins to drift toward the final tension, left unresolved. If motion, rest, identity, and meaning can all exist inside limits, then what does it mean to return to ordinary speeds carrying this knowledge? How does one come back down without losing the calm learned at the edge? That question does not demand an immediate answer. It simply lingers, steady and unhurried, waiting for the moment when motion begins to slow, and the universe gently hands perception back its familiar shapes without asking you to forget what you've seen beyond them. As ordinary motion fully reclaims the foreground, a final realization settles quietly underneath everything else. The universe never expected you to operate at its extremes. Light speed, horizons, and relativistic limits are not goals. They are reference points. They exist not to be reached, but to define the shape of what is safe, stable, and possible at human scale. This reframes the entire journey. You were never meant to live near the speed of light any more than you were meant to live inside a star. These regimes exist to anchor reality, not to host consciousness. They form the deep architecture that allows gentler environments to exist at all. Calm depends on violence being kept at a distance. Even perception itself relies on this separation. Vision requires light to arrive in order, not all at once. Thought requires time to move forward predictably. Memory requires causality to behave politely. The universe enforces these conditions long before awareness ever appears. In this sense, light speed is not an exotic phenomenon. It is a guardian. It ensures that information remains sequenced, that events do not overlap incoherently, that reality does not shout everything at once. Silence, spacing, and rhythm are enforced by physics itself. Human consciousness is exquisitely tuned to these enforced rhythms. We think in seconds, not nanoseconds. We live in meters, not light years. Our nervous systems evolved under constraints that match the universe's preferred pacing. Nothing about your experience is accidental. It is calibrated. When physics explores extremes, it is not seeking escape. It is mapping the edges so that the center can be trusted. Scientists push toward limits, not because they want to live there, but because understanding the boundary explains why the interior is stable. This is why extreme physics rarely feels actionable in daily life, yet profoundly reassuring when understood. It tells you that the universe has already handled its most dangerous possibilities. Runaway infinities are blocked. Contradictions are isolated. Chaos is bounded. Living far from light speed is not ignorance. It is privilege. You exist in a region where cause follows effect gently, where space behaves intuitively enough to navigate, where time grants memory instead of erasing it instantly. This region exists because limits hold elsewhere. The calm you feel now is not the result of learning a fact. It is the result of recognizing that the universe is competent. It does not rely on constant intervention. It does not teeter on the edge of collapse. It maintains itself with quiet discipline. This discipline does not feel authoritarian. It feels parental, firm but not oppressive, protective but not intrusive. The universe does not smother experience with control. It simply prevents the conditions under which experience could not survive. At this point, Curiosity softens into appreciation. You no longer need to imagine traveling at light speed to feel connected to it. Its influence is already present in every moment you inhabit. Every second that passes in order is evidence of that limit quietly doing its work. This is where wonder becomes sustainable. Not the sharp wonder of spectacle, but the slow wonder of reliability. A universe that shows up consistently is far more astonishing than one that constantly surprises. As thought begins to loosen, there is no cliff to fall from. Understanding does not demand vigilance. You can release attention without losing coherence. The universe will not misbehave while you rest. If sleep arrives here, it does so supported by physics as much as biology. Time will continue. Light will obey its limits. Causality will hold. You do not need to supervise reality for it to function. And if wakefulness lingers a little longer, that too is fine. You can remain here aware of motion without urgency, curiosity without pressure, existence without demand. Nothing essential is being missed. The universe is vast, but it is also careful. It allows questions without requiring answers. It allows exploration without insisting on arrival. It allows rest without stopping motion. Within that care, you are already exactly where you need to be. As the sense of scale finally settles into something almost familiar, one last layer reveals itself, quieter than all the others. It is not about speed or limits, or even understanding. It is about trust. Not emotional trust, but structural trust. The kind that exists when a system proves again and again that it will not collapse simply because you stop paying attention to it. Physics at its deepest levels does not demand belief. It demonstrates reliability. Light continues to move at its constant speed regardless of observers. Time continues to order events even when no one measures them. Space continues to expand without asking for acknowledgement. The universe does not require your awareness to function correctly. This realization carries an unexpected relief. Much of human tension comes from the feeling that something must be managed, fixed, or actively held together. But the cosmos does not operate that way. Its most important rules are not fragile. They do not depend on vigilance. They persist quietly, whether anyone is watching or not. Near the limits of physics, this persistence becomes obvious. Even as explanations thin out, structure remains. Even as intuition fails, consistency holds. The universe does not unravel when comprehension reaches its edge. It simply continues in ways that remain internally sound. There is a deep kindness in this. Reality does not punish ignorance. It does not demand mastery as a condition for participation. You are allowed to exist without understanding space-time, just as you are allowed to breathe without understanding oxygen chemistry. The universe carries its complexity on your behalf. This is why extreme ideas eventually circle back to something simple. Not simplicity of explanation, but simplicity of requirement. You do not need to do anything special to belong here. You do not need to move faster, think harder, or grasp infinity. Existing within the limits is enough. At human scale, this manifests as continuity. Days follow nights. Memory accumulates instead of resetting. Bodies persist. Stories remain coherent. All of this is made possible by constraints far beyond everyday awareness. You live inside a carefully regulated reality, without ever feeling its grip. Understanding this does not make life feel mechanical. It makes it feel supported. The universe is not improvising moment to moment. It has already chosen stability over spectacle, coherence over chaos, limits over collapse. Your experience unfolds inside those decisions. As this awareness deepens, urgency loosens its hold. the pressure to optimize every moment fades slightly. Not because time is meaningless, but because it is dependable. It will move forward whether you chase it or not. You do not need to race it to justify your existence. Curiosity can now rest beside acceptance. You can wonder about light speed without needing to conquer it. You can think about cosmic limits without feeling dwarfed by them. They are not looming threats. They are boundaries doing their job. This is where all becomes sustainable instead of overwhelming. The universe is vast, yes, but it is also restrained, disciplined, and quietly consistent. Its size does not erase you, it holds you. As thought slows here, there is nothing left to resolve, no paradox demanding closure, no edge requiring explanation, just a sense that reality, at its deepest level, is not hostile to rest. And with that, attention naturally begins to soften, not because it has run out of content, but because it no longer needs to stay alert. The universe is steady, motion is governed, limits are in place. What remains is a calm awareness that you are inside something enormous, but also something dependable. And that combination, vastness without volatility, is rare enough to deserve a moment of quiet appreciation. That quiet is not empty. It is full of structure doing its work invisibly. And it holds even as consciousness begins to drift. As this long journey gently settles, the ideas that once felt abstract begin to feel familiar, almost domestic. Speed, light, limits, motion. They no longer press for attention. They rest quietly in the background, like distant stars you don't need to name to know they are there. What remains is not information, but atmosphere, a sense of having wandered far without ever leaving the room, carried by concepts large enough to stretch the imagination, yet steady enough to support it. You might remember moments from earlier, the thought of approaching light speed, the way space narrows, the way time softens, the way arrival dissolves into endless approach. You might remember laboratories late at night, instruments listening for faint signals, scientists tracing boundaries rather than crossing them. Or maybe you remember none of that clearly at all. Both outcomes are fine. This was never about holding on to every detail. Now, awareness returns to something closer. The room you're in, the quiet weight of your body, the familiar rhythm of time moving forward again without effort. The universe outside continues expanding, enforcing its limits, maintaining coherence, all without requiring anything from you. You are not responsible for holding reality together. That work is already done. If you're still awake here, that's okay. And if you drifted off somewhere along the way and are only now resurfacing, that's even better. These stories are built to be porous.
They allow attention to come and go without consequence. Nothing important is lost when sleep arrives. In fact, sleep may be the most honest response to a universe that proves again and again that it can be trusted to continue without supervision. There is something quietly comforting about knowing that the deepest rules of existence are not fragile. Light does not suddenly change its speed. Time does not forget how to order events. Causality does not unravel when no one is watching. The universe is not improvising. It is disciplined, patient, and consistent, qualities that make rest possible at every scale. Tonight's question, what you'd actually see at the speed of light, was never meant to be answered in a way you could carry visually. Instead, it opens a feeling, a recognition that limits are not obstacles but guardians. That motion does not require arrival, that understanding does not require control, and that curiosity can exist without urgency. As you settle here, There is no pressure to reflect further. You don't need to summarize anything or form conclusions. The ideas can fade naturally, like light dimming at the edge of vision. What matters is not recall, but reassurance. The universe you live in is vast, but it is also careful. It allows complexity without chaos. It allows mystery without danger. Thank you for spending part of your night here, for trusting this space with your attention, your curiosity, or your sleep. It means something to share quiet questions across distance and time. Knowing others may be listening under different skies, at different hours, held by the same underlying structure. If you feel like it, you can leave a small comment saying where you're listening from and what time it is for you right now. There's something grounding in seeing those moments line up across the planet. And if you'd like more nights like this, slow science, big questions, no pressure, you're always welcome to subscribe and return
whenever you need a calmer place to wander. For now, there's nothing left to chase. The speed of light can return to being invisible. The universe can continue doing its quiet work, and you can rest inside it, knowing that motion is governed, limits are held, and nothing essential is asking for your effort anymore. Wherever you are, however awake or asleep you may be, the night continues gently, and the universe, vast and patient, continues with you.